When we poured our slab, we put 3,000 feet of half-inch oxygen barrier PEX in it, and that was going to be our heat for the house. We had anticipated using a gas-fired high-efficiency boiler to heat water. We were going to pump that through the slab, and that was going to do the heating. The mini splits we installed were originally only intended to be air conditioning, so we sized about 30 kBTU of air conditioning capacity, which should have been more than enough for this house based on the energy calculations I did. And then we'd have up to 80,000 kBTU, maybe 100,000 kBTU of in-floor heat. Unfortunately, we're first-time home builders. There's lessons to be learned. You kind of gotta suck it up and grow. But in the winter of 2021, we had been extremely careful to make sure that we never damaged the PEX in the floor, and that took a lot of effort because everything from when they poured the concrete, we made sure they had to be careful about making sure the PEX got into the slab, made sure that they didn't use any tools that would nick it and put holes in it. We had the entire PEX system filled with water, and we had it all manifolded together so that we could have a pressure gauge on it and make sure during the pour that we never had a nick that would cause a leak. And then again, when they came back 2 days later to cut the control joints into the slab, we had to make sure we got a special saw to make sure that it couldn't go deep enough to hit the PEX. And after the completion of that, we checked the pressure gauge again. It's still all hooked up, it was still good. We actually poured our ICFs in 2 levels. We poured the first level from footing to just above grade, so we could come back and pour the slab. And then we came back, we had our contractor come back on a second occasion and put the walls up from that at grade to final top plate elevation. And they had to put strong backs up against the wall and then brace them to the slab. So again, we had holes being drilled into our slab with tap cons going in to support the braces that were holding up the walls during the pour. We had the manifold gauge on there. We were checking it to make sure that every hole that went to the concrete slab didn't result in a puncture. Come November, December, it's starting to get cold. We don't really have the heating turned on in the house yet. And we decide, okay, it's time to disconnect the radiant heat PEX tubing and blow out the lines. So we cut the gauge off, we got an air compressor hooked up to it, and blew all the air we could out of the radiant heat lines. And we basically blew air through there until we weren't getting any more water on the output. Come January, it gets extremely cold. We had some negative 20 degree days. The inside of the house wasn't insulated at the time, so it definitely got down in that range. Come January or February, March, it starts to warm up. We're starting to work on hooking up utilities, doing things like installing the natural gas pipeline, installing the electrical, getting the load panel hooked up. And by, maybe May of the 2022, we were able to hook up our boiler and get the boiler turned on. And so we had the boiler turned on, and now we were starting to plumb in the radiant heat in the floor. I had pressure tested it the year before. I assumed it was good, so I bought the manifolds, I bought all the fittings, the pumps, everything I needed to hook up a radiant heat system. And that stuff is extremely expensive. The manifolds are about $1,000 a piece, maybe $1,500. The pumps are $300, like all the plumbing, you need expansion tanks, double check valves, all these different things. And I had gotten that all hooked up, and I went to go start filling the system, and for some reason I couldn't get pressure up, and I was confused. And eventually it came down to it where I started disconnecting each individual line, capping the opposite end, and pressure testing each individual line. And I guess we can walk in here and take a look, but as it turns out, 9 out of our 14 lines had substantial leaks in them. And so I white taped everything that had a leak, I black taped everything that was, that tested good. And it's like, whoa, where did these leaks come from? Like, we had been extremely careful, we had pressure tested, we had made sure that we were being very careful to blow them out the year before. Like, this is a nightmare because at this point it's like, May, August, and we're looking at winter coming, in a couple months, and we have no way to heat the house. And so I went back and attempted to blow them out again, and got a ton more water out the second time. And as it turns out, when they're all manifolded together, you can't just blow on one end of the manifold and have it blow out all the lines, because all it does is actually short circuit through the shortest loops. And those ended up being the ones that survived. And in retrospect, it seems like the stupidest thing I could have possibly done. I mean, why did I not disconnect them and make sure I blow out the water in each individual line, or, you know, go back and fill them with glycol, or, you know, these are the things that you learn from experience, because you guess you have to have this happen to you once. But I mean, I had been under the impression as an engineer that PEX is a freeze-tolerant material where it'll stop functioning when it freezes because you get a plug in it, but you can't break PEX with freezing. And so I mean, I was careful to make sure I blew them out, but I wasn't super careful because I had assumed that I couldn't damage the PEX in a freeze event, and that turns out to not be the case. So here we have, you know, $2,000 in manifolds that are hooked up and can't be used, and we have a boiler that only operates domestic hot water heating when the central heating loop is running, and we really can't use any of it because all we have is a couple awkward loops that are things like the entryway or the guest bathroom, or just kind of these useless short loops that we don't really do anything with. I spent probably the better part of a year kind of looking for ways to back myself out of the situation. Could I, you know, pinpoint the leaks and dig up the slab and repair them? Could I, you know, put some sort of leak stop in there to, you know, plug the holes and get it running again? And, you know, at the end of the day, I've talked to enough professionals about this. There's no way to fix it. This is a loss. This is a mistake that is unrecoverable, and you know, at the end of the day, probably wasted $10,000, and that's crazy. But that's by far the biggest mistake I've made due to my lack of experience so far. So at some point, I really just gotta cut my losses and cut these things off at the floor so I can get the space back and move on. Nonetheless, we have a boiler, and that's supplying our hot water for domestic hot water for like bathtub showers, things like that. So we have to have a heating loop hooked up. And it seems like a massive waste to have a heating loop hooked up that is circulating but isn't actually doing anything for us. So where we can, we've started to take advantage of the hydronic heat that we do have. One place is we ended up putting PEX in this gigantic great room wall, and what we're going to do is have it heat the wall, and then we'll get some radiant heat from the wall into the great room. So this is an extremely ineffective way to do it, because heat is very convective. It wants to rise, so usually you want to put fins like this under the floor, but we did it in a wall because we had a ton of cavity available, and we have radiant heat for free. This in total probably cost us $200, and we'll just plumb that back in as a loop on our 4-channel manifold for the house. We put blocking in every 4 feet or so to make sure that if we do get convection and all the heat does end up rising in the stud cavity, it kind of pools up here, and we get some heating on this part of the wall before it just all goes up and hangs out at the very top of the wall. So that was kind of an attempt to do that. We ended up putting some insulation in there. This serves 2 purposes. The mechanical room is very loud, and it happens to be in our living room, which was kind of an unfortunate design choice. So hopefully that'll do some sound dampening. And then also, it's going to make sure that the heat ends up on this side of the drywall, not on the other side of the drywall, because there's utilities and things back there that we don't actually want to be baking at 150 degrees Fahrenheit. So we'll drywall over this. Hopefully we'll get a little bit of heat out of it. I'm estimating 2,000 to 5,000 BTUs, which is really nothing, but it'll be a little boost. Again, I said when I designed the house, I designed it to be heated with radiant heat. So we're gonna have 80 kBTU, which was far in excess of the capacity we needed. But then when we lost that, we all of a sudden had to rely on the heat pump capacity of our mini splits. And I hadn't even chosen the mini splits to be like hyperheats or anything like the kind that would operate at sufficiently high efficiency during a coldest day. I ended up getting a carrier unit, which is just a white labeled equivalent of the Medea that is almost every mini split in the United States. They're Toshibas, they're Medeas, they're the Dakins, they're all the same unit. But it happens to have the Mitsubishi kind of hyperheat functionality where on a -4 or negative 20th degree day, it's still capable of doing its full rated output, which is 30 kBTU. And based on the energy calculations I did, that should be just barely enough to heat the house, which is a very uncomfortable spot to be in because if you're not able to heat your house, things freeze, and that's just completely unacceptable. We need a source of emergency heat. And so in the future, I'm probably going to be taking greater advantage of this hydronic heat we have available. I'll probably put in a heat exchanger somewhere in the mini split system so that I can have a water to air heat exchanger and pump hot water into the heat exchanger while the mini splits are running so that they get a BTU bump of, in a little tiny heat exchanger like this with the 400, 500 CFM of a mini split can do tens of thousands of BTUs per hour, which would be more than enough to keep us safe during a cold snap. Another thing we have working for us is there's a massive amount of heat capacity in this house because we're on a slab, and that makes it very hard to get the house up to temperature. But once at temperature, it makes the house change temperature very, very slowly. Even on our hottest days when we don't have the air conditioning on, we'll shut the air conditioning off at, say 72 degrees and come back that night after a day where it's been baking in the sun at 90 degrees outside all day, and we'll have gotten up to like 75. So the house changes temperature extremely slowly, and how that benefits us is even during the coldest days of the winter, it's likely that we'll be in the low zeros during the day when the mini splits can operate efficiently and pump a lot of heat into the house. And then it's only probably going to dip into those really low -10s, -20s that we get every 5 years at night. And at that point, it's really okay if the mini splits are not keeping up because the house will have enough heat capacity to ride through that dip. So yeah, we're still working on a solution for providing guaranteed enough heating during the coldest possible design days. But for now, we've got enough heating capacity to probably make us through this winter. We'll have the radiant heat wall as a little bit of backup, and then we've always had our 5 kBTU output fireplace. And again, 5 kBTU is like nothing. It's like 2 kilowatts of heat. But hopefully between those 3 things, it'll be enough heat to keep us going until we can get a more permanent emergency heat solution installed. And really, I kind of have to be careful in designing this emergency heat system because I don't want to derate the efficiency of our system during the literally 99.5% of days where we don't need the emergency heat. The Novembers, the Decembers, the January 1st through 14th, and then the February through the rest of the year. I don't want to put a whole bunch of resistance in the system to account for those 3 days every 5 years that the system can't keep up. So I'm careful about installing a heat exchanger because I know that's going to force my mini splits to run their fans a lot harder. And with these mini splits, they take almost no energy, so the fan really is the only electrical load, only major electrical load during normal operation. And I don't want to spike that up just because it has to push through a heat exchanger that's almost never actually has hot water in it. So I'm kind of thinking through my options there. But that's kind of where we're at. Once we got the house up to temperature last year, we had no problem really maintaining temperature. We had ceiling drywall up, but we didn't have wall drywall up. We definitely didn't have any of the joints sealed, and especially around the corners and things like that, there were massive gaps, and convective losses are huge. They're everything in keeping heat in a house. So now that we've got no sealed, we're gonna be a lot better than we were last year. We only have like R11 or R13 in the ceiling, and we really just did that so we could get some heat in the house during last year's heating season. We're on the fence about taking that out or leaving it up there because we want to go up there with spray foam and seal around the cans, and maybe put the little hats on them for the energy efficiency. And then we're going to blow in R55 of cellulose insulation. And between those 2 things, we're going to be much, much better than we were last year. Last year was good enough. Last year was kind of a mild winter, but we're hoping between those 2 things we'll be good until we can come up with a better solution. And there's a difference between the live-in solution, which is where it can never dip below 70 degrees on the coldest day, and then we need it to work for another winter while we're constructing, which is we got to make sure it stays above 50 or 45 during the coldest days. So I think we're gonna be okay, but that's kind of the situation we're in. If you are installing your own radiant heat system, definitely do test it with water. Don't use air, because if you get a nick, you could have an explosion and you're probably gonna hurt somebody. But if you do use water, maybe fill it with glycol. This is a good option because it doesn't take that much glycol. It's probably, like 10 gallons or something like that. And stuff's like $2 a gallon at Menards. Or make sure you blow out each individual line before winter comes, because despite what everyone seems to think and what I thought, that PEX was freeze tolerant, it apparently is not. And you can have catastrophic, irreparable damage if you leave water in your lines over winter. So, yep, like I said, it's this is the first time we're doing really any of this, and I'm a practicing engineer. I work with these sorts of things and these sorts of systems all day, every day, but I've never really worked on the residential side, and I've never really worked on a full project from start to finish, with concrete, drywall, all of those factors. And so I'm still learning, and I'm still making mistakes. And as much as it hurts to, throw away $10,000, it's, you kind of got to move on. You can't let that consume all your mental energy, and you kind of just got to, make sure you're careful and avoid the mistakes you can, and keep going. So that's where we're at. This is our radiant wall. It's raining outside today. We've just started to put up the strapping for our rain screen before we get our siding delivered next week. We're doing the hardy plank equivalent called a lure board. And like I said, it's raining, it's a mud pit out there. We can't really do anything outside today. So we're thinking about hanging the last couple sheets of drywall and getting this covered up. And once we get this covered up, we only have like two or more sheets in here. We've got a small sheet along this wall here, and then we got the ceiling, and then we're officially done with hanging drywall. And I don't just think about hanging drywall probably again for the rest of my life, unless one of my friends doesn't heed
calls in a favor,
doesn't heed my experience, and decides to build their own house themselves, and ends up in the same situation. I don't even really know how to drywall in here because we have so many penetrations. We've got the intake and the exhaust for the boiler. We've got the gas. We got that big mess of piping for the conduit. In the industrial spaces, I've seen they just cut a big rectangle out and then go back with pre-fill or plaster or whatever and just do a nasty job of caking it on around the pipes. But I don't know, maybe I'll look into a little more. That's kind of why I haven't come and just hung the ceiling yet. We've also considered just doing plywood. I think plywood would give us the same problem, but for the walls, the plywood is really nice because it makes hanging stuff really easy. And it's stuff like the boiler, the electrical panel, the lighting controller need to be mounted to studs, obviously, but everything else can kind of get mounted to the 1/2-inch plywood. So things like our Raspberry Pi and cellular router that's currently giving us internet connection and doing temperature monitoring and stuff like that, and just all the little small accessories that you need to mount to the wall are really easy to mount to plywood because it's got some holding strength. So yeah, that's the story with our radiant heat. If you have experienced this, if you've found workarounds or you've made this mistake yourself, let us know your experience, because that's a big part of our YouTube channel. We're looking for the experience of people who know more than we do. Unfortunately, it's usually a little too late, but yeah, go ahead and drop a comment and tell us about your experience. Tell us how it went wrong. Tell us how we were idiots. Just let us know. So it's a couple hours later, and we got the last kind of interior wall up. We used what's left of our 54-inch drywall, and just had a little piece we had to cut off on the bottom, because I think the wall's like something a little over 10 feet. But yeah, it went really quick. We're actually finally getting quick at hanging drywall now that we're done.